So what happens when we go beyond element number 18 with 18 electrons? Well, obviously you can see that as we go from the first principal energy level to the second, we gain a sublevel. So in the first energy level we had just an S. The second one we had an S and a P. Third principal energy level we have an S sublevel, P sublevel, and what we end up doing is not creating, but there exists a D sublevel. And as we go to subsequent higher principal energy levels, we will gain another sublevel. Let's go back and take a quick refresher of what these boxes represent. So the boxes represent the orbitals. The s orbitals are spherical in nature. Remember, these are probability functions that describe regions in space where we're likely to find the electrons. The scattering of the dots, where that scattering is most dense, that's the greatest probability of finding the electron. If we compare the S sublevel for the first, second, and third principal energy levels, we see that as we go higher in energy at the third level, that region in space becomes larger and larger. In other words, the electrons have a greater and greater tendency to be farther away from the nucleus. When we look at the P sublevel, remember, had 3 orbitals. Well, again, these orbitals come as a result of the probability functions, Schrodinger's equation, and they describe 3 different regions in space. Those 3 different regions in space happen to look like dumbbells, and they're oriented on the axes of the 3 coordinates. And the D sublevel has 5 orbitals, 5 regions of space predicted by the probability functions of the Schrodinger equation. And these happen to have, 4 of them have 4 lobes to them, and one has what's called a torus with a dumbbell. The tricky thing about these, from a philosophical standpoint is, how do 2 electrons occupy all 4 of these lobes at once? Well, that's where we get into the wave part of the electron. So remember that, we decided from de Broglie that electrons or matter can have both particle nature to it as well as wave characteristics. And so from that standpoint, the electron can exist in all 4 of these lobes in the D orbitals. For our use at this level of biology, we aren't going to have to worry too much about the D orbitals and ones that go farther up. What we're going to do is look at trends in the periodic table and look at electron configurations and how they're related to the position of the elements in the periodic table. And so we'll be able to kind of scoot by without going into too much depth about the electron configuration. But just so you're aware of it, things do get slightly more complicated as we go even farther up. One of the issues that occurs is this overlap of orbitals. And what happens is that the 4s orbital is actually lower in energy than the 3d orbital. So when you go to put electrons into the atom, they actually go into the 4s orbital before the 3d. So this is something we'll tackle in chemistry next year, as we need to go into more depth with these. And if you keep going up farther, you see that indeed it gets even slightly more confusing. We add the f orbitals in there in addition to the d's. But again, at our level, we're going to be able to stick to just the s's and the p's and trying to understand that valent shell of electrons, which is the critical part, is being able to understand how many electrons are in the outer shell of our elements.